Greeting, ladies and gentlemen. Today video I'm gonna answering the question 12. A piston cylinder device contains 0.1 meter cube of liquid water and 0.9 meter cube of water vapor in equilibrium at 100 kPa. Heat is transferred at constant pressure until the temperature reaches 315 degrees C. Question A asking what is the initial temperature of the water. So this system consists two states, the first one and the second. At the first stage, the pressure that will be at 100 kPa. The condition of the matter were in liquid and vapor. Liquid will have a volume about 0.1 meter cube, and the vapor that will be 0.9 meter cube. At the second stage, after a while, the system will heat up. The temperature will rising into 315 degrees C at the constant pressure that will be at 100 kPa. Been asking at the first stage what it is the temperature. So if I tend to answering this question, I'm refer to the thermodynamic table, saturated water pressure table, table A5. I'm respecting the table upon the pressure because been given at the first stage at 100 kPa. So if you go through to the list, you will find at 100 kPa, it will have a saturated temperature 170.41 degrees C. So that will be the first condition, the first temperature for the first, that will be the temperature for the first condition. Now, one might ask me, why did you didn't take note upon the compressed or the superheated table? It is because at the first stage, the system, half of it, not half, but some of it were in the form of liquid, and another that will be in the form of vapor. So this means this system at the first stage were in saturated condition. So that's why I'm referring to table A5. So question B asking total mass of the water. I make an analysis at the first stage of the system. You can make an analysis at the second stage of the system, and yet you will get the same answer because it is the closed system. There is no mass in and mass out. So I make an analysis at the first stage of the system, and total will be the unknown that we want to find out. It is equal to, logic to say, the mass of water that were in liquid plus by the mass of the water that were in gas or vapor. So mf plus by mg, it is also equal to specific volume of F over by the volume of F, the power by -1 plus by the specific volume of gas over by the volume of gas, the power of -1. So specific volume for the liquid you can find in the table, which is in here, 0.00115. You will get you can find the value of Vg 0.24035 from the table, and been given the value of Vf and Vg. The value of X is the ratio between the mg over by m total, or it can derive in the form of volume Vg over by V total. Since that the Vg will be equal to 0.9 and the total for the volume for both vapor and liquid will be 1, so our value of X equal to 0.9. There is no unit because there is a constant. So 0.9, you'll get all of the parameter that you need, that you will require. So you can include upon this equation. Thus, you will get 93.43 kg. So that is the mass total for the entire for the water in the entire system, because it is a closed system, there is no mass in and out. So next question asking calculate the final volume. The final volume, first thing first, we need to make a graph for the first and second condition. In this case, I'm draw the saturated graph. There is a saturated graph, the graph that you can see like a hill, and it is the water heated process graph. You will have the latent heat, you will have the C value of energy, and in this case the water would heat up from 170.41 degree into 315 degree at the constant pressure at 100 kPa. So from the table A6, since that been asking what is the calculate the final volume, so the point of analysis is at the second stage. Now at 100 kPa and 315 degrees C, what is the condition of the water in the system? That is, first we need to classify, then you can classify the volume by the condition of the water. So you need to refer to saturated table first. Been given that that will be at 100 kPa and the temperature will be 315 degrees C. So at 100 kPa, respect to saturated water pressure table, you will have a temperature about 170.41. So indeed, the condition of the water were not insaturated. Since that it will have a high temperature, so it is mean this system for the second stage, the water were in superheated. So you go through to the table A6 at 800 kPa. We need to convert into megapascal because the table we're using megapascal. So we get 0.8 megapascal. So refer to the table. Bring the ruler lower a little bit. Now, at 0.8 megapascal at 315 degrees C, the specific volume of the system were 0.35442 in the form of meter cube per kg. So that will be 0.35442 meter cube per kg. All the mass now were transformed into gas. Thus, 0.35442 meter cube per kg, you need to times it by 93.43 because you need to cancel out the value of kg in here, because the question asking what is the final volume, not specific volume but final volume. So you need to eliminate the value of kg in here by times the this value by the m total. Like I said previously, this system were enclosed, so there is no mass in and out from the first stage to the second stage. So the mass were conserved. So you can use the mass that you define in the first stage in the second stage. So that's why the value of mass will be 93.43 times by 0.35442. You will get the final volume for the system that will be 33.1 meter cube. So I think that's all for today. Thank you for watching and have a nice day. Bye bye.